Alright, and welcome to Graphing Linear Functions, Level 3. Now, here in our very first example, we want to graph the linear function passing through the point 4, comma negative 3 with a slope of negative 2. And let's do a couple things. First, let's go ahead and circle or underline point 4, comma negative 3, and let's underline a slope of negative 2. Now remember, in order to graph a function, you always need a slope and a y-intercept. So we already know our slope is this negative 2. Remember, the word slope can be represented by the letter m. However, we really don't know what our y-intercept is in this case because we're not given a function. So when we're given a point and a slope, we actually want to use something that's called point slope form. And that is y minus y1 equals m parentheses x minus x1. And you should remember this from your Algebra 1 class. Now from here, where do you get all of these pieces? Well, we look at our point 4, comma negative 3, and we actually want to label it x1, y1, because it's our first point. And we're going to go ahead and plug that in. Notice we've labeled this x1, y1, so when we see the letter y, or over here when we see the letter x, we're just going to leave those as y and x always for point slope form. So we'll do y minus, I look back up here, what I labeled y1 was negative 3 equals, and our slope m is going to be negative 2, x minus, we look back over here to our point that we labeled, and it turns out that 4 is going to be our x1 value. Now from this line we can actually do two steps. One, we see that we have a negative and a minus sign, or I'm sorry, minus and negative, and we know that two negatives actually make a positive. So we can write y plus 3 equals, and over here, let's go ahead and distribute that negative 2. So we have negative 2x, and negative 2 times negative 4 would give us positive 8. Now remember, in order to get our formula here into slope-intercept form, we have to get this y by itself, and so you'd ask yourself, how do I get rid of this plus 3? Well, minus 3 and minus 3. And so at this point, we have y equals negative 2x, and 8 minus 3 will of course give us 5. And at this point, we now have enough information to go ahead and graph this function. We know our slope is negative 2, and we see this constant here, 5, that must be our y-intercept. So let's go to our graph, and for our y-intercept we can go 1, 2, 3, 4, 5 units. We'll put a point. And remember, our slope we always want to write as a fraction, negative 2 over 1. And what is that telling us? Well, on the top we have our change in y, which is telling us to go down 1, 2. And on the bottom we have this positive 1, which is our change in x, is telling us to go to the right 1. So we count down 1, 2, to the right 1, and we can put our very first point. Now remember, a linear function always has a constant rate of change. So from our first point to our second point, we went down 2 and to the right 1. Then from our second to our third, we'll go down 2 and to the right 1. And now that we have these 3 dots, or 3 points, we can draw a line through them and graph this function. Now from here, I'm not going to spend too much time on it, but remember from our level 1 and level 2 videos, unless we restrict the domain or range in some way, form, or fashion, our domain and range of linear functions will always be from negative infinity to positive infinity. And so our range is also negative infinity to positive infinity. And now at this point, this is going to bring us to our very last section. And if you can do me one favor, go ahead, pause the video, finish taking these notes, and I'm about to erase what I have over here so I have a little bit of space to work. So I'd pause it. Okay. Alright. Let me just clear up just a little bit of space, because the last key feature that we want to find is going to be our X-Intercept. And it should be pretty apparent from the graph, when we look at our X-Intercept over here, it's not crossing at a perfect integer point. So let's see. So we'll go back here, and for my X-Intercept, remember the key is we always want to set y equal to 0. And so when we had that function y equals negative 2x plus 5, well, instead of writing y equals, we'll just put 0 equals. And from here, to find the x-intercept, all we have to do is solve for x. So we can subtract 5 minus 5. 0 minus 5 will, of course, give us negative 5 is equal to negative 2x. That goes away. And remember, to get x by itself, we simply divide both sides by the coefficient in front. And so it turns out our x-intercept will be at positive 5 over 2. Don't forget that a negative divided by a negative is, in fact, a positive. Okay? So our x-intercept is 5 over 2. And if you know fractions pretty well, you should know that that is actually 2.5, which makes a whole lot of sense. Alright, pause this video, finish taking any notes that you need, and let's move on to our second example. Okay, let's take a look at example 2. It says graph the linear function passing through the point 0, 5 with a slope of 3 over 2. So the first thing we want to do is always underline our relevant or key information, and then I think we should label it. When we look at this point, and we know that we're ultimately going to be using point-slope form, which is y minus y1 is equal to m parentheses x minus x1, well, what do we want to label this point? Well, we're going to label it x1, comma, y1. And of course, we know that slope stands for the letter m. And in fact, where I have you label our slope and y-intercept, we can even go ahead and write in 3 over 2. So let's fill in all the things we know. We see that y and x never change for point-slope form, so I have y minus, but as I look over here, I see my y1 is a positive 5, is equal to our slope that we labeled was 3 over 2, parentheses, x stays the same, minus, and then as I look over here, I see that our x1 value is going to be 0. Now from here we can actually do some pretty nice things. We know y minus 5 doesn't change, so y minus 5 equals, and over here we can distribute. 3 over 2 times x is 3 over 2x. Now we could do 3 over 2 times negative 0, but what is any number times 0? Well, since that gives us 0, we can actually leave the rest of this space over here blank. So now, in order to finish this problem, all we have to do is get y by itself. How would you get rid of a negative 5? Well, plus 5, and so once that zeroes out, we get this formula, y equals 3 over 2x plus 5. And now we can go up here to our y-intercept, and we know that our constant is positive 5, and we can graph it as such. And at this point, we have enough information to graph our function. Don't forget, our b term, our y-intercept, is where we start, and it's a positive 5, so we can go 1, 2, 3, 4, 5 up, and put our very first point. And our slope is 3 over 2, so let me even kind of label that here more explicitly. 3 over 2, this is our delta y over delta x. And since our 3 is positive, that's telling us we're going to go up 1, 2, 3. And since our 2 is positive, we're going to go to the right 1, 2. And now we have our next point. Now I want to show you all a cool little trick here. See, we've actually ran out of room at the top of our graph. And so if I wanted to go up 3 and to the right 2, well, we've essentially ran out of space. So a cool trick is that if our slope is 3 over 2, which sends us up 3 and to the right 2, you can actually completely reverse that. And so instead of going up 3, we can go down 1, 2, 3. And instead of going to the right 2, we can go to the left 2. And so I go down 3 to the left 2. And you'll notice this point is still on that same line. So it's a cool little trick in order for you to graph in the other direction. Now, one thing we won't really touch on too much here in this video, we should know at this point the domain of any linear function is going to be negative infinity to positive infinity. And we should know the range is going to be from negative infinity to positive infinity as well. The last thing we want to look at, let's take a look at our our x-intercept. And don't ever forget, our x-intercept is where y equals 0. So when I look at this function right here, instead of writing y, well, we can write 0 equals 3 over 2x plus 5. And ask yourself, what should be our first step? Well, we want to get rid of our constant. We want to get rid of our addition or subtraction. So minus 5, and now I have negative 5 equals 3 over 2x. And don't forget, when you have a fraction in front of your variable, rather than dividing by that fraction, it's much easier to multiply by the reciprocal. And so the reciprocal of 3 over 2 is, when you flip it, 2 over 3. And so what we do to the right, of course, we'll do to the left, and I'll change that negative 5 into a fraction, negative 5 over 1. And to finish this problem off for our x-intercept, don't forget the rule for fractions is we multiply top by top. So 2 times negative 5 will give us negative 10 over, and on the bottom, 3 times 1, which will be 3. And so our x-intercept is at negative 10 over 3. And if you know fractions pretty well, that's just a little bit more than 3, and so it would be in between negative 3 and negative 4. Alright, I hope this helps, and I'll see y'all in our level 4 video.